Dear students, welcome back to Chem Aspire. This is Part 12 Corrosion Lecture Series. In this video, we are going to discuss about one of the methods of control of corrosion, which is modification of the environment. In the previous videos, we have discussed about how proper designing of the metal can reduce the rate of corrosion or control corrosion. In this video, we are going to discuss about how modification of the corrosive environment will reduce the rate of corrosion. There are various methods by which the corrosive environment can be modified, altered so that the rate of corrosion will be less. So first one is de-aeration and deactivation. De-aeration or deactivation is nothing but removal of oxygen from the corrosive environment. We know that large amount of corrosion when it is present in the corrosive environment, the rate of corrosion will be more. So we have to remove the oxygen from the corrosive environment. For removing the oxygen from the corrosive environment, certain chemicals such as sodium sulfite and hydrazine are used, and these chemicals such as sodium sulfite and hydrazine are called as oxygen scavengers. What happens when these chemicals are added to the corrosive environment? These chemicals will remove oxygen from the corrosive environment so that the rate of corrosion will be less. So what is the equation for it? Sodium sulfite, when it is added to the corrosive environment, it will react with the oxygen that is present and it will be converted into sodium sulfate. And similarly, hydrazine, when it is added to the corrosive environment, it will remove oxygen and it will be converted into nitrogen and water. So this is called as de-aeration or deactivation. This deactivation can also be done by a mechanical agitation. By mechanically agitating the corrosive environment, oxygen can be removed. And similarly, deoxygenation can also be achieved by lowering the temperature of the corrosive medium. So by adding chemicals, we can remove oxygen. By the agitation, we can remove oxygen. And by lowering the temperature of the corrosive medium, we can remove oxygen from the corrosive environment. So if oxygen is removed from the corrosive environment, the rate of corrosion will be less. So this is regarding to de-aeration and deactivation. The second one is dehumidification. Dehumidification is the process of removal of moisture from the corrosive environment. So this can be achieved by using certain chemicals such as alumina and silica gel. When the chemicals like alumina and silica gel are added to the corrosive environment, these chemicals will absorb the moisture and the moisture content of the corrosive environment will be reduced. By this way also we can control the rate of corrosion. So this is regarding dehumidification process. The third one of modification of the corrosive environment is alkaline neutralization. We know well that if the corrosive medium is more acidic in nature, the rate of corrosion will be more. So we wanted to remove the acidic environment and make it neutral in nature. For that, we are adding certain alkalis. So what are the alkalis that we can add in the acidic environment? We can add agents like lime, caustic alkali, ammonia gas, naphthenic soaps. So when these alkaline agents are added to the acidic environment, neutralization happens and therefore the rate of corrosion will be less. So this is the third method of modification of the corrosive environment. Now, the fourth type of modification is corrosive inhibitors. Let us know what are corrosion inhibitors. Corrosion inhibitors are nothing but chemicals which, when added to the corrosive environment, reduces the rate of corrosion. What are corrosion inhibitors? They are the chemical substances which, when added to the corrosive environment, decreases the rate of corrosion. So we have two types of corrosion inhibitors. One is anodic inhibitor and the other one is cathodic inhibitors. So let us know what is anodic inhibitor or anodic inhibitors. Anodic inhibitors are nothing but chemical substances which, when added to the corrosive environment, they reduce the anodic area. So what are the chemical substances which are acting as anodic inhibitors? They are phosphates, chromates, molybdates, benzoates, etc. So these chemicals are called as anodic inhibitors. So what they will do when they are added to the corrosive environment, these chemicals will form a protective layer on the surface of the anode so that the rate of corrosion will be less. But there is a drawback with these anodic inhibitors, because when these anodic inhibitors, when it is added to the corrosive environment, they will form a protective layer. And if the protective layer formed is not proper, and if there is any crack in between, then severe type of corrosion will happen. Therefore, these inhibitors, that is anodic inhibitors, are also called as, they are called as dangerous inhibitors. Anodic inhibitors are called as dangerous inhibitors. The second type of inhibitor is cathodic inhibitors. What are cathodic inhibitors? Cathodic inhibitors are chemical substances which, when added to the corrosive environment, reduces the cathodic area. Normally, when corrosion reaction can happen in a acidic environment or in a neutral environment. We know that when the corrosive environment is acidic in nature, what is the cathodic reaction? The cathodic reaction is nothing but evolution of hydrogen. So the H plus ions from the acidic environment, electrons that are coming from the anodic reaction, they will combine and there will be evolution of hydrogen in the cathodic region. So for in this acidic solution, so the cathodic inhibitors that are commonly employed are amines, mercaptans, heterocyclic nitrogen compounds, ureas and thioureas. When these substances, when these chemical agents, if any one of these chemical substance is added to the acidic solution, what happens is that these chemicals will decrease the diffusion of H plus ions towards the cathode. Since they are decreasing the diffusion of this H plus ions into the cathode, right, the rate of corrosion will be less. So this is with respect to the acidic solution. Suppose, say, if the corrosive environment is neutral in nature. If the corrosive environment is neutral in nature, what is the cathodic reaction that is happening? We know it is a formation of hydroxide ions at the cathode, because it is a neutral environment, we have OH minus ions, and there will be a presence of oxygen and electrons from the acidic region. So there will be a hydroxide ions that will be produced in the cathodic region. So for this type of neutral solution, neutral corrosive environment, we are using salts such as salts of magnesium or zinc or salt of nickel. So what happens when these salt of this magnesium or salt of zinc or salt of nickel is added to such a neutral environment? These salts will form a insoluble hydroxide with that of the OH ions that is formed in the cathodic region, and these insoluble hydroxides will be forming a membrane. It's like a protective layer on the surface of the cathode, and this will form, since it is forming a protective layer on the surface of the cathode, the cathodic reaction will be less and the rate of corrosion will be less. So in this lecture class, we have seen how the modification of the environment can decrease the rate of corrosion. We have seen that it could be achieved by 4 methods. One is aeration and deactivation, dehumidification, alkaline neutralization, and use of corrosive inhibitors. That's it for today. We'll continue in the next class. Thank you.